So this presentation is on inner and outer joins and what the differences are between those. So previously we've looked at various relational algebra operations, including selection, projection and Cartesian product, things like that. And the way that we've done inner joins is to use a Cartesian product and a selection. And in relational algebra we use this little bow tie symbol, and it sort of looks like this. So an inner join, if we actually have this sort of notion of an inner join in itself as an operation, it basically means everything combined from one table is combined with everything from another table, but only on some condition. So you can see that we write that down with R, which is a table, it's a relation. S, which is a table, again it's a relation, and underneath that we write our little condition, which is F. So the way that we've done that previously is to do it like this. That's the notation that we use in relational algebra. So we've Cartesian product R and S together. In other words, everything from R is combined with everything from S. And then we've used that selection to throw stuff away. We throw away the rows that don't match. So here's the notation. So these two things would do exactly the same. The notation on the left, which is the little bow tie, that's the actual inner join notation. That would do the same thing as the thing on the right. The thing on the right means do Cartesian product, combine the two tables together, and then throw away everything that doesn't match. And the example that we've used over and over again is the one involving the emp table and the department table. So let's do an inner join on those, and you can see that table there. And if you scan across, you can see we have the emp table on the left, we have the department table on the right, and we're only keeping rows where the department number is the same. In other words, we have emp.department number 2, department.department number 2, 3, 3, 3, 3, 3, 3, 1, 1, etc. all the way down. So everything is combined from the two tables, and we keep information where there's that matching column, that column that's in both tables in this instance, which is department number, and we match on that department number value. Now the way that we do that in SQL looks like this. So we've got our three standard words there, select, from, where, and here's how we construct that inner join. After the from reserved word, we have the tables that we're going to combine together, emp, comma, department, we just separate them with a comma. And then on the third line, we have that where reserved word. And after where, we have the clause, which is basically the predicate, the condition. How are we going to join those tables together? And here, as we saw on the previous slide, we're going to say department number from the first table has to match department number from the second table. And when we run that, that's the result we get. Now that's called an implicit inner join syntax. What we're really doing there is we're using a Cartesian product and a test. So in other words, we've got emp, comma, department, that's the Cartesian product, and we've got our test, our predicate, that's the bit where we're going department number equals department number. And that's the way that we've done it on the course so far. Now, when SQL92 came out, they decided to introduce a different way of doing an inner join, and that's with an explicit inner join syntax. This is the actual layout of the syntax here, and really the changes are on the second and third line. You can see if you look at the from line, our clause that now comes after that basically is something, then the reserved words inner join something. So in other words, emp inner join department. You'll see that example in a minute. On the third line, we use, instead of using a where clause, we use on. So we go field, operator field. So for example, it's the same as we had before. We're going to go on department number equals department number. So let's have a look at the original example again. Here it is. And you can see how we, instead of using a comma, we now have an inner join. And instead of using where, we now have on. And if we run that, we get the same result set. Now, originally, most databases were quite strict about using select, from, on, but I think, for example, in things like MySQL, if you forget to use the on and you use where, it's quite forgiving. So you can use select from where. Personally, I never use this notation because I just forget about using it. I forget to use the on, and so I always stick with the Cartesian product and the selection anyway. It's entirely up to you. You can use whichever one you wish. So let's have a look at an outer join. Now, sometimes when you want to join the tables together, you want to include extra information. And that extra information you can include using this thing that's called an outer join. And we've got two joins here, a right outer join and a left outer join. And in fact, there's a full outer join, which I'll talk about in a minute. I think this is best explained by example. So let's go back to something which is sort of similar to what we were doing before, but let's be quite precise about it. Let's imagine that we had this query which says, show a list of all departments and the employees who work in them. So you start off and you use your implicit join syntax. That's when we go emp comma department, where, blah, blah, blah. And when you run that over our emp and department tables, you get this. Now have a look at the table in the background, which says department number, dname, block, and ename. Now, you look at that and you can see we've got all the people who work in department 1, you've got all the people who work in department 2, and all the people who work in department 3. But there's a department 4. And our query says, show a list of all the departments and all the people who work in them. Now, of course, the problem is that there isn't actually anybody in department 4. So when the two tables are combined together, there's no match. And because there's no match, that means the row 4 operations leads is excluded from our result set. Sometimes what we want to do is we want to include unmatched rows from one of the tables. So we want to actually do that thing where we combine the tables together, but we want to include things that don't match as well. And either we can include things that don't match from the table on the left or from the table on the right. Now what we're saying here, if you have a look at the from clause, you can see it says emp comma department. Department is on the right here, so that would mean that we want to do a right outer join. Combine emp and department together so that we see everything that matches, but also include the extra things from the table on the right, a right outer join, so that we get that fourth department. Now the way that we write that down in relational algebra is to use the bow tie symbol with a little bit cut off on the edge. How do we do that in SQL? Well, there's an explicit SQL syntax that looks like this. If you look at the second line, you can see we use the words left join and right join to actually combine the tables together and include that extra information. So let's try that out. Here we are. That's the original query, but this time using a right join. So combine emp and department together, but also keep extra information from the table on the right, which in this instance is the department table. And if you scan down now in our result set, you can see there's department 1, there's department 2, there's department 3, and then right down the bottom there's department 4. And of course no one works in department 4. So when we look at the ename column, you can see there's just a blank, a null there. But that's what we wanted. We want to see all the departments and all the people who work in those departments, even though no one works in department 4. So that's a right outer join. Obviously a left outer join is where you want to include information from the table on the left. Now a full outer join is one where you want to merge the tables together, but you want to include extra information from both the table on the right and on the left. Now to do this with the data set that we have, we just have to make a slight change to the table. Now if you have a look at the Parker row, you can see currently Parker, if you scan across to the column on the far right, you can see that they're in department 1. So what I'm going to do is I'm going to change this. So I'm going to remove Parker from any department because Parker is a president. So now we have a department that doesn't have anyone in it, which is department 4, and we have a person who doesn't have a department, Parker. So When we do that query again, let's imagine that we wanted this query here. It says, show a list of all the departments and all the people. And if we just do a standard inner join, this is the result we get. Now you can see we don't have department 4 because there's no one working in department 4. And also we've lost the president because the president doesn't have a department. So what we really want to do is we want to include all the people who don't have a department and all the people and all the departments that don't have any people. So how do we write that down? Well, in relational algebra and SQL, it would look like this. So you can see, if you look at the second line, you can see from EMP, full outer join department. And if we run that, you can see now, have a look at the result set. You can see at the top we have Parker. Parker doesn't have a department. And at the bottom, we've got department 4, and department 4 doesn't have any people inside it. So you get blanks. That's called a full outer join. Merge the two tables together, keep all the records where they match, but also keep all the records from the table on the left and the table on the right where there's not a match. However, that syntax works with some databases, but often a lot of databases don't support the full outer join syntax. So we have to cheat. And the way that we cheat is to use a union. We will actually do a left outer join, do a right outer join, and then we'll union them together. So in SQL, it would look like this. So we've got two SQL statements. There's one at the top and one at the bottom. One at the top's doing the left join, one at the bottom's doing the right join, and then we union them together. Now for this to work, it has to be union compatible. What that actually means is, if you look at the columns that come after the select statement, they've got to be the same number of columns and the same data type, so that the department number from the first select statement can be dropped onto the department number from the second select statement. We've got 4 columns and they all line up. That's what union compatibility means. And if you do that, it will work. And that will work in Access, and it will work in almost all databases. It's a bit of a hack, but it does get you there.